We are going to continue with triangles, and this time we are going to look at the law of sines. So the law of sines is going to help us with angles and sides that we don't have, that are unknown. So just remember, when we talk about A, B, and C, we have a triangle. If we have A here, the side length A is here. If we have B here, side length B is here. If we have C here, side length C is here. And so we can use the law of sines to find any missing side or angle. So notice that it's A over sine A, B over sine B, C over sine C. So you just pick two, set them equal, then do a little cross multiply and divide in order to find our missing side or angle. Given two angles and one side, a unique triangle is formed, okay? So if you have two angles and one side, you just have one unique triangle, okay? However, if two sides and an opposite angle are given, then there are three possible outcomes that can occur, and you have to find those. Okay, one triangle results only after verifying second triangle does not exist. Two triangles result as a result of checking for a second triangle. Zero triangle results due to an inverse sine that does not exist. Okay, so we are going to look at this first one. It's a single solution case. So we have two angles and a side. So see how it says given two angles on one side, one unique triangle is formed. So we're going to draw this. I guess we don't have to. We can just write what we're looking for. So we need angle A, we need side A, and we need side C. So we are given B and C. So let's use the B over sine B. So 27.4 over sine of 28.7 equals C, we don't know, over sine C. Okay, so cross multiply. So we have 27.4 sine 102.3. And then if we do this, C times sine 28.7. Then we have to get C by itself, so we divide by sine 28.7. Okay, and so then that is how we find our C value. So do the math, and it comes out to be 55.75. And this is in feet because it's a side. Okay, let's do, well, we can't do side A yet because we got to find the angle A. Well, remember all angles in a triangle add up to 180? So to find angle A, we're going to do 180 minus the other two angles. Okay, so put that in your calculator. And that equals 49 degrees. Okay, also just remember that we're in degree mode because we have the degrees. And we need to be in degree mode when we're doing any kind of the trig functions, and you have a value right beside it, which is in degrees, so that's why we choose degree mode. Okay, then we can do angle A. So I'm going to use that same B over sine B, so 27, or side A is what we're looking for. Sine 28.7 equals A over sine 49. So cross multiply and divide. 27.4 times sine 49 equals A times sine 28.7. So we divide by sine 28.7. Okay, so then we do the math, and we get that side A is 43.06 feet. So that goes here. Okay, you know you're done whenever you have all the side and angle measurements. And this is one unique triangle. And the reason we know that is because we know two sides, A can only be 49. So that's why it's one unique triangle. Okay, let's go to an ambiguous case. Okay, this is when you have two sides and an opposite angle. Okay, so I have B and B. I don't know what angle A is. So let's go ahead and do B over sine B. A over sine A. Okay, this happens whenever sine A is equivalent to another value. There's not just one of sine A. Okay, so we're going to cross multiply and divide. So we have 12 times sine 42 equals 22 sine A divided by 22. And then we get a decimal answer, okay? So we have sine A equals 0.364983, something like that. And so in order to find an angle, we use inverse sine of that number. And that finds our angle A. Put that in. And angle A is a degree, so we put angle A as 21.406. Okay, so we want to find angle A, angle C, and side C. So we found angle A. Okay, so now what we need to do is we need to think about our unit circle, and we need to think about what sine is, okay? So 21.04. So we're thinking about it this way. X, Y. So if we have the angle 21.04, it's an acute angle, so it looks like that. And the sine is the Y value. 21.04 on this side is the Y value. This is a negative X. But see how the sine is the same on both? Sine equals Y. Sine of 21.04, 21.406 is the same. So this tells me that we'll just have one solution. So a way that you can check this is in order to find that we take 180 and we subtract 21.406. That's 158.594. And then we add the one angle we have. So add 42. And it's 200 something, 200.594. Okay, so if it is greater than 180, then you only have one solution, only one triangle. So we don't have to do a separate triangle because we found out we do 180 minus our new angle and then plus the given angle. If it's greater than 180, then only one triangle. If it's less than 180, then we have multiple triangles and we have to find those. So let's go ahead and continue on. Angle C, we do 180 minus the 42 minus 21.406. And that equals 116.594 degrees. Okay, so we use that to find side angle, side C. So I'm going to use that 22 over sine 42 because that's what we already know. That was our given, equals C, I don't know, times sine 116.594. Cross multiply and divide, and we end up like this. And it ends up being 29.400 when we round. So 29.4, and this is in inches. Okay, let's go to the next one. All right, we have C, B, and C. So only one angle is given. So the solution is ambiguous. That means we need to do some work. So let's go ahead and write down what we need. We need, oh, let me fix that. We need angle A, we need angle B, and we need side A. All right, so we'll do the C over sine C equals B over sine B. Okay, so we do the work. So it is 25 times sine 85 equals 15 times sine B, divided by 15. Okay, we end up with like 1.6, and so we have to do the inverse sine to find the angle. Well, when you do this, this gives you an error. Whenever we have the unit circle, the sign is never more than 1. Sine x is not greater than 1. So since there's an error, this triangle does not exist. So we can't even do these. So we have to have working knowledge of that unit circle. All right, let's look at the next one. We have A, B, and then angle A. So this is ambiguous. So we are going to have to check. So let's go ahead and do, we have A and A. We need angle B, angle C, and side C. Okay, so A over sine A equals B over sine B. Okay, we cross multiply and we divide. So sine B ends up being 31 times sine 20.5 over 12. Put that in the calculator and we get a decimal, so we have to do the inverse sine of that. And we get that B is 64.783 degrees. Okay, so we're going to put that here. 783 degrees. All right, so then we have to check how this goes. We do the 180 minus our new angle. And then add it to our given angle. Oh, that's small, right? That's going to be less than 180. So that means that there is more than one triangle. There's not a unique triangle. All right, so what we're going to do is we're going to do this is B1, this is C1, and this is C1. And then we're going to have to find the second triangle, B2, C2, and little c2. Okay, so before we continue on, let's go ahead and find out what the angle 2. So angle 2 is this. Whenever you do 180 minus the angle we were given. No, minus the 20.5. So let's not do that. And minus the 115.21. So these guys. And that ends up being let me get a calculator real quick. 180 minus the 20.5 minus 115.21. No, B2 is going to be 115.21, sorry. This is going to be B2. And then minus that is going to end up being C2. So that's 44.29. Okay, so let's go back over to C to find what C is. And we are going to do the A over sine A equals C over, I got to find sine C. Well, C is going to be found by doing 180 minus the 20.5 minus 64.783. 180 minus 20.5 minus 64.783. 94.717 degrees. So that goes in my ratio. Okay, cross multiply and divide. So it's going to be 12 times sine 94.717 and then divide by sine 20.5. Okay, and that ends up being what side C is, and that is 34.149. And we are in inches. Okay, let's go to triangle 2. All right, so we are going to do C. So we're going to do basically the same thing that we just did, but with a different angle. So we're going to do 12 over sine 20.5 because we still have the same angle A, side A, and side B. So this equals C over sine 44.283 if we were to, expand this. All right, so do the work, and that is 12 sine 44.283 divided by sine 20.5. Okay, and that ends up being 23.924 inches. Okay, so these are the two triangles that we could have given that ambiguous triangle. Okay, I'm going to have you do example 4 on your own. Okay, let's do the last section, which is area of an oblique triangle. So oblique, think about obtuse, right? When one of the angles is greater than 90. Okay, so this tells us that we can find the area of any triangle by doing half the product of the lengths of two sides times the sine of their included angle. So here is our formulas. So normally you find the area by doing half base times height. So this is when you don't know the height. So let's see what we have. So we have sine of C. So that means I'm going to use this formula. Okay, so instead of saying A equals, I'm going to do area equals because we've been saying A equals to talk about angles. So I don't want to get that confused. Okay, so work that out. Have your calculator calculate it for you. And it equals, and we don't know what units, so we're going to put units squared. All right.